So today's kind of a big day. Today's the day that we develop the unit circle. So whatever you see right here, I'm going to show you how we develop it line by line and what it all means. Now we are going to use those two special right triangles that we talked about, the 30, 60, 90, and we're going to scale the hypotenuse to 1. So you got 1/2 and square root of 3/2. And then we're going to take the 45, 45, 90 and scale its hypotenuse to 1. And now we have square root of 2/2, square root of 2/2. Okay, so those are the two that we're using. Let's go ahead and this is nice that we could do this with Notability because it draws circles for us. Nice ones. There we go. Now draw yourself a line coming down here and a line going straight across. That looks good enough. Okay, we're going to start with our 30-degree angle. So I'm going to choose orange for our 30-degree angle. What you're going to want to do is come over about a third of the way. So like if you mark this into thirds like this, something like that, and you mark this into thirds, draw a line from here straight through the origin all the way to this other one. And there you go. So I'll erase this line over here. And then do the same thing on the other side. You can kind of eyeball it. And we're going to make an X. Okay. Now what you're going to do is you're going to draw a line straight down here and straight down here, making a little bow tie. A little bit of artwork, art one. Now we're going to draw some more bow ties here, but this is the first one. This reference angle right here, we're going to call 30 degrees or pi 6 radians. 30 degrees or pi 6 radians. So because it's going to get kind of cramped up in the central angle area, we're going to write 30 degrees right here, and we're going to put pi 6 next to it. Actually, put it a little bit lower, because we want to actually write the ordered pair here. So how do we write the ordered pair? Well, this is why we scaled the hypotenuse to 1. We're on the unit circle, which means the radius is 1 unit. And the radius now ends up being the hypotenuse of the triangle that we just created. So that's why we call the hypotenuse r all along. It's the radius of rotation. So this is 1 unit right here. That's 30 degrees in the central angle right there. This horizontal is square root of 3/2, and the vertical is 1/2, right? Now we can actually name that ordered pair up there, can't we? I have to go right square root of 3/2, and then I have to go up 1/2. So the ordered pair at that place where the terminal ray intersects the axis is square root of 3/2 pi 6, or square root of 3/2 1/2. It's at pi 6, 30 degrees. So what would the cosine of 30 degrees be? Just looking at this picture. The cosine of 30 degrees would be x over r. But when r is 1, do we even need to consider r? No, not really. It's the square root of 3/2 divided by 1. Well, if you notice, the square root of 3/2 is your x-coordinate. And it's also the cosine value, right? And the sine is y over r, which is 1/2 over 1, which is just the y value. So it's going to turn out that as we go all the way around, the cosine is the x-coordinate, and the sine is the y-coordinate. That's pretty impressive. So if you just look at the coordinate now, what is cosine of pi 6? Same angle, right? Cosine of pi 6 is square root of 3/2. What's sine of pi 6? 1/2. It's easy to remember this because two things. First of all, cosine starts with a C and sine starts with an S, right? And in the alphabet song, C comes before S. So the cosine is always listed before the sine. The other way to remember it is that the y value is the sine value. It's the height of your triangle. And if you recall, they have the same sound in them, don't they? Sine, y, height. Sine, y, height, height. Sine, y, height, height, height. Sine, y, height, sine. See that? Makes it easy to remember. Sine. X is just cosine. Yeah. No, it doesn't. X cosine width, X cosine width, width cosine X, cosine width doesn't sound as good. Sine Y, height, Y, sine, height, Y. But also the alphabet song, right? C before S. Now, what is the tangent of this angle? What is tangent of pi 6? We did it in our warm-up, but we could do it again, right? Tangent is y over x. And if you took the y value, 1/2, and you divided by the x value, square root of 3/2, your 2's are going to divide out. And you're left with 1 over the square root of 3, which is square root of 3/3. So you could do that from the ordered pair. If I ask you for tangent, you can get tangent from here. It's 1 over the square root of 3. You don't even have to worry about the denominators because they're going to divide out. It's y over x. That is the numerator of y over the numerator of x. 1 over the square root of 3. That's square root of 3/3. Boom. We got it. Now, if we can get those 3, shouldn't we be able to get the other 3? Yeah, let's see. If cosine is square root of 3/2, which trig function is the reciprocal of that? What name do we give to it? Secant. So secant of pi 6 is going to be 2 over the square root of 3, which when you rationalize it becomes 2 square root of 3 over 3, right? You flip the x to get the secant. The cosecant of pi 6, or 30 degrees, is the reciprocal of the sine. What's the reciprocal of 1/2? 2. So cosecant of pi 6 is 2. And then the cotangent, we can get that much like the tangent. For the cotangent, it's x over y. X over y. The 2's are going to divide out, so it's just square root of 3 over 1, which is square root of 3. And that's what's cool about the unit circle. From one ordered pair that gives you the cosine and sine, you can get the other 4 just by memorizing this little piece of information. Okay? Also notice that 30 degrees is closer to the x-axis. So our triangle is wider than it is tall, yes? And therefore the x-coordinate is bigger than the y-coordinate. Square root of 3 is bigger than 1. It's another way to remember it. But the best way is sine, y, height, y, sine, height, sine, height. All right, let's rotate all the way around to here. This ordered pair, this ordered pair, it's the same triangle. Do you notice that all these triangles are congruent to each other? They're all congruent. So they have the same magnitude on their length. The only difference is, how do I get to the ordered pair? In this case, I go left and up. So this ordered pair is negative square root of 3 over 2, comma, 1 over 2. What are the angles there? Well, let's do the degrees first. What's 30 degrees short of 180? 150. What's pi 6 short of pi? Pi 6 short of pi. Pi is how many sixths? Pi is always easy. You can just give the denominator over itself. So if pi is 6 pi 6, and we're stopping 1 pi 6 short of that, what should it be in radians? 6 pi 6 minus 1 pi 6. 6 minus 1 is 5. So that's 5 pi 6. 5 pi 6. Now, you're going to actually get used to radians, and then you're going to find that you're going to like them a little better. Because when you see 150 immediately, you may not think the reference angle is 30 degrees. But when you see blah, 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 pi 6, you're like, oh, the reference angle is 30 degrees, or pi 6 radians. So it's going to have the same ordered pair. Now that we have that ordered pair listed, let's go ahead and do a little bit of practice with it. What is cosine of 5 pi 6? Cosine of 5 pi 6. Negative square root of 3 over 2. It's the x-coordinate. What's the sine of 5 pi 6? 1/2, right? It's the same as sine of pi 6 because y is positive in these two quadrants. What would the tangent of 5 pi 6 be? 1 over the negative square root of 3, rationalized, is negative square root of 3 over 3. Right? What would be the cosecant of 5 pi 6? If you don't know what they are in terms of x, y, and r, this is going to be hard for you. I would memorize that as soon as you can. What's cosecant of 5 pi 6? Cosecant's the reciprocal of which one? The y, or the sine. So what's the reciprocal of a half? 2, right? 2. What would secant of 5 pi 6 be? Secant flips the cosine, and you get 2 over square root of 3 negative, which when you rationalize is negative 2 square root of 3 over 3. Negative 2 square root of 3 over 3. If you're still kind of having a hard time thinking about how they pair up, here's one thing that might help you remember this. Cosine and secant are reciprocals of each other. If you say cosine backwards, COS backwards, what is it? What if you say COS backwards, you get soc, right? Which is almost sec. Or if you say sec backwards, you get kiss, which is almost kissine, right, dude? Kiss, kissine, sec, kiss. I don't know if that helps or not, but they're inverses of each other, they're reciprocals of each other, that is. All right, moving straight down here. If we go down to this point right here, what's 30 degrees past 180? 210 degrees. And what is it in radians? What if I go pi 6 past 6 pi 6? 7 pi 6. Good. And the ordered pair there is negative square root of 3 halves, negative 1 half. You may see 210 and not realize the reference angle is 30 degrees, but when you see blah, 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 pi 6, you know it's going to be a pi 6 reference angle. And you know the ordered pair is going to have magnitude square root of 3 halves, 1 half. The only thing you have to do is figure out which quadrant it lives in. 7 pi 6 is just bigger than pi, so we're in quadrant 3 where they're both negative. What's cosine of 7 pi 6? Negative square root of 3 over 2. Yeah, what's sine of 7 pi 6? Negative 1 half, so on and so forth. What's tangent of 7 pi 6? Tangent's y over x. Y over x. Y over x. Y over x. When you take the division here, the 2's will divide out. That's why we rationalized them. Now I have negative 1 over negative square root of 3. Well, a negative over negative is positive. Yeah? And 1 over the square root of 3, when you rationalize it, is square root of 3 over 3. So that's the answer. Yeah. All done? Yeah, thank you. You need a pass? No? Okay. How about, my favorite ratio, one of my favorite ratios. What is secant of 7 pi 6? Secant. We flip the cos, right? Cos is secant, backwards. If you flip square root of 3 over 2 negative, you get 2 over the square root of 3 negative, which when you rationalize is 2 square root of 3 thirds negative. So negative 2 square root of 3 thirds. I'll write that one down. That one's kind of hard to visualize. Just real quickly off to the side here, the secant of 7 pi 6 is negative 2 square root of 3 over 3. Flip it, rationalize it. You should be able to do these in your head with a little bit of practice. Flip it and rationalize it. But notice it's another pi 6 reference angle. I'm going to erase the labels over here on the sides. I'm going to come over here to this point, and this point is, the ordered pair is right and down. So it's positive square root of 3 halves, negative 1 half. The angle there, 30 degrees short of 360, is 330 degrees. And what is pi 6 short of 2 pi? We're stopping pi 6 short of a full rotation. What's that? What pi 6? No, 5 is over here in quadrant 2. That's pi 6 short of pi. This is 2 pi, which is how many pi 6? 12. What's 12 minus 1? 11. That's 11 pi 6. 11 pi 6. And now we can go through all 6 if you want. What's cosine of 11 pi 6? Cosine of 11 pi 6. Square root of 3 over 2. Thank you. Cosine is the x. Cosine is the x. Sine is the y. What's sine of 11 pi 6? Negative 1/2. That's easy. Sine. What's tangent of 11 pi 6? Negative square root of 3 over 3. Good. The 2's divide out again. It's y over x. It's negative 1 over the square root of 3. I'll do that down here. Tangent of 11 pi 6. That's going to be negative 1 over the square root of 3. And when you rationalize it, I'll show you the rationalization. You get negative square root of 3 over 3. But you should be able to do that in your head with a little bit of practice, because they end up being the same ratios all the way around. The only difference is the sign, right? The SIGN, depending on where the angle terminates. All right, so there is your pi 6 or 30-degree reference angle. So good so far? All right, let's go to your 60-degree angles. So now come up here to this top third and draw a line through the origin down here. You only need 2 points for a line. So there's the first one. I'll erase this. And then another one over here. And then we make a bow tie by drawing it straight down. Straight down. In a different flavor. I used a different flavor. You don't have to. Now, this is your 60-degree reference angle, which is pi thirds. It's the exact same triangle that we just used. The only difference is we're turning it up on its head. So what are the dimensions now? Well, now it's 1/2 square root of 3/2. Now it's taller than it is wide. And guess how this is going to work? The same way. We're going to say, what is cosine of 60 degrees? It's the x, right? It's 1/2. If you want to do it from the triangle, you can. It's 1/2 over 1. The radius or the hypotenuse is 1. What is sine of pi thirds? Square root of 3 over 2. Now it's important. These two ordered pairs are just flipped from each other. Students tend to get those confused. Like if I ask what is cosine of pi thirds, students want to say square root of 3/2 instead of 1/2. Okay? When we are closer to the y-axis, like at 60 degrees or pi thirds, our triangle is taller than it is wide. So the y value is the bigger number, and the cosine is the smaller number. 1 is smaller than square root of 3. Okay? What would the tangent of pi thirds be? Not quite. Tangent is y over x. And the 2's in the denominator will divide out. Square root of 3, right? Excuse me. It's square root of 3 over 1, which is square root of 3. That's right. What would the secant of pi thirds be? Secant is the reciprocal of cosine, right? What's the reciprocal of 1/2? 2, right? What would be the cosecant of pi thirds? Cosecant flips the y, so you flip it and you get 2 over root 3, and then you re-rationalize it and you get 2 root 3 over 3, okay? Got the idea? We're moving along. Now the next angle over here, we're 60 degrees short of 180. This is 120 degrees, and what's the angle that goes along with it? Well, we're pi thirds short of pi. What's that going to be? Now we can call pi not 6 pi 6, but we'll call it 3 pi thirds. And we're stopping a third short of 3 pi thirds, which puts us at what? 2 pi thirds. 2 pi thirds is the same as 120 degrees. 2 pi thirds. And the ordered pair is negative 1/2, positive square root of 3/2. It's the same ordered pair, just with different signs. So what would cosine of 2 pi thirds be? Anybody can shout out. Everybody's thinking through it if you're not shouting it out, right? Cosine of 2 pi thirds is negative 1/2. It's negative 1/2. Sine of 2 pi thirds. Square root of 3 over 2. Yeah. What's tangent of 2 pi thirds? Negative square root of 3. Good. Now, we're going to eventually quiz over this. The first quiz that we take, which probably will be tomorrow, is I hand you a blank unit circle and you fill in everything around the perimeter in 5 minutes. And then the next day, we start taking our using the unit circle quizzes, where I give you 10 of these random things like cosine of pi thirds, sine of 2 pi thirds, and you just fill in what the answer is. Okay? And then we get faster and faster. We do 10 and 10. And then we do 10 and 8, and then we do 10 and 5, and then we do 10 and 3. Okay, which is the fastest I'll make you go. But really, you're just memorizing a couple of things, and you're figuring out which quadrant it lands in. Yeah?
How do you define the fractions for each of the points if you just are given the degree?
You memorize them.
Okay.
Yeah, you got to memorize them. Now, I'm not going to quiz you with degrees. I'm putting degrees on here just so you can kind of have a relative idea of where we're at, but we're going to be quizzing with radians. Yeah. Because radians are easier. If you see 2 pi thirds, you know the reference angle is pi thirds. And you know the ordered pair is 1/2 square root of 3/2. All right, speaking of, down here, the ordered pair is negative 1/2, negative square root of 3/2. And if I'm 60 degrees past 180, where am I? 240. And then the ordered pair in radians. Well, what is it when I'm pi thirds past pi? 4 pi thirds. Fantastic. So cosine of 4 pi thirds is negative 1 over 2. Sine of 4 pi thirds is negative square root of 3 over 2. Tangent of 4 pi thirds is positive square root of 3. Because it's a negative over a negative. What would the cotangent of 4 pi thirds be? Cotangent, remember, is x over y. 1 over the square root of 3, positive. And then you rationalize it to get square root of 3 over 3. There you go. See, it's not that bad. When you see it develop like this, it makes a lot of sense. All right, and then the last 60-degree angle down here, to get to that point, we go right 1/2, and we go down square root of 3/2. And now the angle is going to be 60 degrees short of 360. That's 300 degrees. Or what is it in radians? What is pi thirds short of 2 pi? 5 pi thirds. Excellent. It's 6 pi thirds minus 1 pi thirds, which is 5 pi thirds. So cosine of 5 pi thirds is positive 1/2. Sine of 5 pi thirds is negative square root of 3 over 2. Well, what's cosine of pi 6? Yeah, I switched back to another angle. Cosine of pi 6 is square root of 3 over 2. But sine of 5 pi thirds is negative square root of 3 over 2. Questions so far? We got one more set of interiors to go. And I'll call that your purple. So now you could just draw a line from the middle point of these two. And draw a line coming down here. That one didn't work so well. Let me try that again. Come in at a 45. That'll have to work. All right, and then do one on the other side. And then draw your bow tie. So now you can see 4 more congruent triangles in purple. I'm not shading them in because I don't want to obscure the others. But guess what the reference angle is now? They're all 45-degree reference angles, all of them. So when we do the 45s and we scale the hypotenuse to 1 because it's the radius, now I got, this one's the easy one. Square root of 2 halves, square root of 2 halves. They're the same. They're, bless you, the exact same. So when I come over here, the ordered pair is square root of 2 halves, square root of 2 halves. The angle is 45 degrees, or pi fourths radians. So pi fourths is 45. Pi fourths is 45. 45 is pi fourths. So to get to that ordered pair again, we go right square root of 2 halves and up square root of 2 halves. If you want to draw that, that kind of helps at the beginning at least. So now what's cosine of pi fourths? Cosine of pi fourths? Square root of 2 over 2. And what's sine of pi fourths? Square root of 2 over 2. If you remember from geometry, your 45, 45, 90 triangle was an isosceles triangle. Remember that? It still is isosceles. That's why the two sides are the same. Okay? What would the tangent of 45 degrees be? It'd be 1. Because what's anything divided by itself, including square root of 2 halves? 1. What would cotangent of pi fourths be? 1. That's x over y. Very good. That's x over y. What else do we have? Oh, here's a good one. These require a little bit of work. What would the secant of pi fourths be? Secant of pi fourths is going to be the reciprocal of the x, right? What's the reciprocal of square root of 2 over 2? 2 over the square root of 2, which when we rationalize gives me 2 square root of 2 over 2. And what happens with the 2's? They divide out, and I get what? The square root of 2. So here's an important thing to help you speed up. The square root of 2 over 2 and the square root of 2 are reciprocals of each other. What's the square root of 2 over 2's reciprocal? Just the square root of 2. And what's the square root of 2's reciprocal? Square root of 2 over 2. So what would the cosecant of pi fourths be? No, that's the sine. The cosecant is the reciprocal of sine. What's the reciprocal of square root of 2 over 2? Just square root of 2. Just square root of 2. You don't want to have to re-rationalize it every time. What's the secant of pi fourths? Square root of 2. And what's the cosecant of pi fourths? Square root of 2. Right. But the cotangent of pi fourths is what? 1. And the sine of pi fourths is what? Square root of 2 over 2. But the cosine of pi 6 is still what? Square root of 3 over 2. Good. All right. What funny word?
All of the ones you say.
Oh, I know. I wasn't there when we named them. All right, let's mosey over to this point right here. This point is negative square root of 2 over 2, positive square root of 2 over 2. And to get there, it's 45 degrees short of 360. What's 45 short of of 180? 135. Very good. Now, you could do this one. What is it in pi fourths if we stop 1 pi fourth short of pi? 3 pi fourths. Because pi is 4 pi fourths. Good. 3 pi fourths. So again, it's easy to spot the pi fourths reference angle because you're going to see pi fourths. 3 pi fourths. You know it's going to be the same ordered pair, square root of 2 halves, square root of 2 halves. But now you know it's in quadrant 2 because 3/4 is just less than 1. And now you know it's left and up, so it's negative positive. All right, coming down here, the ordered pair is now going to be negative square root of 2 halves Negative square root of 2 halves. They're both negative. And the ordered pair is what in terms of degree? I'm sorry, degrees. The right angle is 180 plus 45? 225. Good. And then what is pi fourths plus pi? 5 pi fourths. Very good. What is sine of 5 pi fourths? Negative root 2 over 2. What is cosecant of 5 pi fourths? What is the reciprocal of the square root of 2 over 2? Negative root 2. Good. Because the reciprocal of square root of 2 over 2, as we already saw, is just the square root of 2. What would the secant of 5 pi fourths be? Negative square root of 2. What's the sine of 5 pi fourths? Negative square root of 2 over 2. And the cosine of pi 6 is still? Thank you. Square root of 3 over 2. I don't know why you said negative. Maybe that's just your personality. You think that way. Right? Okay, the last one over here. We know the ordered pair is going to be positive square root of 2 halves, negative square root of 2 halves, because we're in quadrant 4. 45 degrees short of 360 is 315. And what is pi fourths short of 2 pi? What pi fourths? Yeah, 7. Good. Because 2 pi is 8 pi fourths now. And 8 pi fourths minus 1 pi fourths is 7 pi fourths. So what would the sine of 7 pi fourths be? Negative square root of 2 over 2. What is the tangent of 7 pi fourths? Not 1. It's negative. Now you're not thinking negative when you should. It's negative square root of 2 halves over square root of 2 halves. Those divide out to give you negative 1. And what is the cosecant of 7 pi fourths? Negative square root of 2. Thank you. Because the reciprocal of the square root of 2 over 2 is just the square root of 2. Nice. What would the tangent of 5 pi fourths be? 1. Because it's y over x. Y over x. They are exactly the same. Negatives divide out to give you 1. Good. Good, good, good. What's the secant of 225 degrees? Wait, that just sounded weird. I don't usually use degrees. What is the secant of 5 pi fourths? Negative 2. Yeah, square root of 2. Negative square root of 2. Secant is the reciprocal of x, the cosine. Flip it, rationalize it, you get negative square root of 2. Awesome. That takes care of all your internal angles. Internal angles. And really, all you got to do is memorize just a few things, and then you can apply it to the other quadrants. Now, we do have some other guys that are still lingering. What other angles have we not done yet? What's a good color that I can use here? They're all contrasted already. Black, red, bright red, brown. Beefy brown, beefy, beefy. We have these angles here. This is the ordered pair 1, 0. Because remember the radius is 1. We go to the right 1 unit and not up at all. This angle is 0 degrees. Sorry, I'll do it up here. This angle is 0 degrees or 0 radians. They're different. You need both zeros. 0 degrees, 0 radians. You can put 0 pi if you want to. Now this is what type of angle? An angle that terminates on the x or y axis. Remember what we called it? Larry? Do we call it Larry? No, Larry is what you call the little Twitter bird. Did you know that? It's on the board today. The strange or fancy, weird fact of the day. The Twitter bird actually has a name. His name is Larry. We didn't call this guy Larry. We called him one of the quadrantal angles. Remember that? Quadrantal angles. Quadrantal angles. So let's go ahead and see if we could do what we've been doing. What do you think the cosine of 0 is? It's 1. Cosine of 0 is 1. If you remember when I showed you this the other day, think of it as coming from 90 degrees. We're taking our triangle and we're bringing it all the way down to the x-axis. What's happening with the width as we do that? It's getting bigger and bigger, approaching the maximum 1 when we squish it all the way down. Now, what's the sign of 0? 0, because when we're on the x-axis, the height, sine, y, is down to nothing. So the sign is 0. Got it? Sign is 0. Cosine of 0 is 1. Maximum value it could be. Sine of 0 is 0. All right? Let's do some others. What would tangent of 0 be? Also 0, because it's 0 over 1 now, right? Y over x, that's tangent. What would cotangent be? Very good, Katie. It does not exist. It's x over y. That's 1 over 0. That's dne. That's all you have to put, dne. Some type of infinity. What about what have we not done yet? Secant. What's secant of 0? 1. Because secant's the reciprocal of cosine. And if cosine is 1, secant is the reciprocal of 1. And what's the reciprocal of 1? 1. It's not by flipping a finger. You basically have 1 over 1. And you flip the fraction and you still get 1 over 1. So what's the reciprocal of 1? 1. What's the reciprocal of negative 1? Negative 1. What's the reciprocal of the square root of 2 over 2? Just the square root of 2. Very good. Very good. What would the cosecant of 0 be? It's the reciprocal of 0, right? Is the reciprocal of 0 0? It's dne, because remember, 0 is really like 0 over 1. And when you flip 0 over 1, you get 1 over 0. It's dne. So there are two of them that are dne, right? The cosecant is dne, and the cotangent is dne, because they both have a 0 in the denominator. No good. All right. We're not going to quiz tomorrow. Don't worry about it. This is also 360 degrees and 2 pi radians. I'm just going to go ahead and finish up here. The quadrantal angles, here's another one up here. This is the point 0, 1, and this is 90 degrees and pi halves radians. So what's sine of pi halves? Sine of pi halves? Sine, y, height, sine, y. 1, right? Sine of pi halves is 1. We've now collapsed the triangle down horizontally. So now the width is 0. What's the cosine of pi halves? 0. That's why the width is 0. Okay, and if we just keep going around here, you'll see that you get the ordered pair negative 1, 0. And this is, of course, 180 and pi. So we're familiar with that. What would the secant of pi be? Secant of pi. Secant of pi. Secant is the reciprocal of cosine. If cosine of pi is negative 1, what's the reciprocal of negative 1? Negative 1. So the secant of pi is the same as the cosine of pi. And then we got this fellow down here. This is, of course, 0, negative 1. And this is going to be 270 degrees, also known as 3 pi halves. We've seen him before. And then rounding out all the way around, we get the 360 and the 2 pi. That's coterminal with 0. Now, I would start memorizing this right here. There are certain patterns. We'll talk about those tomorrow. But if you want a clean copy of this, this is the clean copy. And when we quiz, probably on Monday, you're going to be filling in a blank one of these. That's just a circle with the dots around the perimeter. And at each dot, you're going to put the angle in degrees, radians, and the ordered pair. Okay? No, that's the next one after that. All right. We'll call that a day. That was a good day. Hopefully you were participating in your head, if not out loud. Unit Circle.